All right, so let's do a couple more pretty quick rows graphs, starting with r equals 5 times sine of 3 theta. Now, as we mentioned before, since this guy is odd, that means that we are going to have exactly that many petals. So we're going to have three petals. Now, since we don't get to double that like we do when it's even, we still want to keep that in mind though. So 3 petals, we really do have 6 regions, but it's going to be every other one that has a petal. So my R is going to be 5. So let me go ahead and, well, I guess we might be just a little bit, no. We have 5 here. Yeah, that's going to be fine. So, you don't have to do this. I like having this here as kind of like a boundary for me, and it helps me get the shape much more nicely. Now, we know with, we know with sine that there's going to be symmetry about that, the y-axis, but it's like, where do we start? Where do we go with this? So, here's my suggestion to you. Because this is sine, we can do the divisions on this actually very nicely. Because we know that sine, when you start at theta equals 0, he starts right here at the pole, right? So we expect it to kind of do, a petal out there, and then where's it going to go after that? So my recommendation, we know there's going to be 6 regions. So if I take 360 degrees divided by 6, we should have 6 60-degree regions, right? And because we expect this guy to start to kind of be along the polar axis first before curving back, that means that we can go ahead and start with one of the divisions here. Now, fortunately for us, 36 divided by 6, 60, it's going to divide very nicely. So you've got this one, and then every 60 degrees, which is going to be at all of these pi over 3 marks. All right, so you see that we have 6 divisions. It's like a Trivial Pursuit token, right? It's got the 6 little pi pieces. The max value that we're going to have is going to be in the halfway spot. So I know I have a petal here, so this max is going to be at that midway point, which is going to happen at pi over 6. And you can definitely check that out. If I were to replace this with pi over 6, 3 times pi over 6 is pi over 2, and that's when sine maxes out at 5. But it's going to happen in every other region. So this region is going to be empty. He's going to have a max over here, empty here, and he's going to have a max down here, and he's going to be empty right there. All right, so let's use this to build our picture. Again, for these, there's a certain amount of accuracy we want to have, knowing where these maximum points are, but some of it is just going to be kind of, past the eye test. Now, as I graph around this is going to be my first spot. So imagine that I'm curving and I'm hitting this, and I come back to the origin. What makes sense for the next region is going to be down here. So this is going to be my second spot. He's going to curve back and hit this one for my third one. All right, so let's see. We're going to draw this out as long as we have the right color for that. All right, so here we go. We're going to hit this guy. I'm going to come back through here and hit this one. And then coming back over here into this region, let me turn my drawing tablet because it just makes it easier for me to draw that. And then we're back home. All right, so here is our graph. Hopefully that makes sense what we did there. But again, let's go to the graphing calculator. Let's check this. Let's play around with things and make sure we understand how it all works. So 5 sine of 3 theta. Right, so it did the region of the first quadrant that came down here and then over there. And again, you can see that we have nothing in this area or here or here. And that's what you're going to see whenever you have an odd number on the inside. You divide it up into, in this case, 2 times 3, so 6 regions. Every other one has a petal, and then the others are empty. All right. Now the next one here says 4 cosine of 4 theta. Well, I see the 4 here. It's even, so that means that the number of petals I have will be 8. So we have 8 petals. All right, so with 8 petals, we're going to have 8 divisions. So we have a radius of 4, so let's put that there first. So my radius is 4. Again, you don't have to do this, but I think it's very helpful. All right. If we divide this up into 8 regions, that's going to be fairly simple because it's already broken up into 4 regions because of the quadrants, right? So just keep breaking it down. I should be able to find 8 regions very easily. So there's these 2 guys, the obvious suspects. And if I break this down again, it's going to happen at the pi over 4s. Now you're going to see that because I break it down this way and I'm working with cosine, it's actually going to work a little bit differently. Because when I start with cosine, as long as there's not a negative in front of this, he starts already at his max value right here, which happens to be where that division, where I drew that dark blue division line, right? But there's going to be that symmetry here, and so it's going to happen at every single one of these guys right here. Now, had this been sine, if I cross out the cosine, I write sine, we could still have the same divisions, except we would know that sine wouldn't be maxing out at the dotted lines, it'd be maxing out in the middle right here. So you'd have your petals being inside like that. But for cosine, these dashed lines that I drew are going to actually cut those petals in half. The next part here is to figure out, well, where do I go, right? If this is my first spot, where's the next one? Well, all these divisions are happening at the basically every pi over 4, right? So if I plug in pi over 4, so 4 times cosine of 4 times pi over 4, those guys reduce. I would have 4 cosine of pi, so that would be negative 4. So the first place that I get to at pi over 4, he'd actually be pointing back here to the negative 4, so this would be my second place that I would go to. And then I would plug in pi over 2. And at pi over 2, you plug that in right here. That becomes 2 pi. Cosine of 2 pi is 1, so you're back at 4. So this is going to be the next one. And you'll be able to see the pattern here is that when I would be here, I'd actually be kicking back over here. And then this is going to be for 5. And we're going to be here at 6, 7, and this is going to be my 8th petal. All right, so let's sketch that out. So starting over here, I got to go from 1 to 2. So I've got my petals going through where it's connected there with the origin. And once I make the turn at 2, I got to head back up to get to the 3rd one. And then from here, we got to go to 4. And then from 4, again, there's no problem in turning your page, rotating your page so that you can draw things better. Okay, you gotta find 5. And then we got to curve back to 6. And we're going to go to 7. and then we hit 8 before we finally curve back to our starting point at 1. So there we have our rose with 8 petals. And again, let's check that out. So we've got 4 cosine of 4 theta. Yeah. So by having that theta step be so small, it makes the calculator here slow down a little bit. Now, if you're just doing this at home, you could probably just do, say, pi over 180, and it would take your calculator long enough to process that you'll be able to see it slowly graph it out in the same order that we have. All right, one more video to do here, and it's going to be about one last weird little shape that, oddly enough, will connect back to these roses. All right, so stick around.